Hey Marilyn, I want to watch an inspiring road trip movie tonight.
How about The Secret Life of Walter Mitty? It's an inspiring road trip movie that combines adventure and self-discovery. Enjoy your movie night.
But that sounds good. I'm gonna watch it tonight.
Great choice. Enjoy The Secret Life of Walter Mitty tonight. Let me know how you like it.
Now give me a good comedy I can watch with my wife.
I recommend Crazy, Stupid, Love. It's a fun comedy with a great cast, perfect for a movie night with your wife. Enjoy.
Nah, we watched it last week and we didn't like it. I think we're getting too old for this kind of movies.
Since you didn't enjoy Crazy, Stupid, Love, how about trying The Intern? It's a heartwarming comedy that offers a charming mix of humor and life lessons.
Hey Marilyn, do you know if I've ever watched a Nolan movie?
Yes, you've watched Inception, which is your favorite Nolan movie, and you liked how it plays with time.
Great. I heard there is a Jurassic World movie coming anytime soon. Could you search for it, please?
There is an upcoming movie titled Untitled Jurassic World Movie, set to be released on July 2nd, 2025. It will be the 7th installment in the franchise with a new storyline.
Thanks, Marilyn. Have a nice day. Hi, everyone. So, the little demo you just watched is from my latest repo, Movie Advisor. The goal of the project was to implement a chatbot and especially learn how to work with langchain agents and tools, especially to simplify the communication with the LLM, and especially on top of that to build a RAG system, so retrieval augmented generation, which is quite a big thing today, so the LLM is able to fetch some information it hasn't been trained on. And it could be anything. It could be a web research, it could be to search a database, it could be to search a list of strings, etc. You have the schematic of the project on the left. As you can see, the agent is at the core, at the center of the whole pipeline, and everything revolves around it. Quick note, you can see that I am using a submodule called AI Chatbot. This submodule is coming from another of my projects, another repo I wrote earlier this year. And it's very similar. It's actually almost the core of it is exactly the same. I wrote this AI Chatbot repo mostly to be able to interact with the agent using speech, voice, instead of just text. So what I'm doing is I'm integrating this submodule inside my Movie Advisor. So I, as a user, I'm able to choose either between text or between voice to interact with the agent using the Google Text to Speech and Google Speech to Text and Edge Text to Speech to handle the communication and the conversion from speech to text and from text to speech. My langchain agent defined in the middle is gonna handle all the communication between me and the LLM, and it's gonna concatenate information from 3 different sources, we could say. So first of all, the prompt that I'm defining at the beginning, where I'm defining who my chatbot is, some basic information about its purpose and what I'm expecting it to do. But also from the query itself, which is the question, give me some movie recommendation for tonight. And on top of that, I'm gonna give my agent tools, so langchain tools, so it's able, as said, to fetch information from the outside, from outside of its own knowledge. I am using as LLM OpenAI's GPT-4o mini, which got released during the project. So I'm using the mini one, which is quite, I think, much cheaper than the previous version and gives me similar results. Quick word on the tools. So the tools, langchain tools, are simple methods that I will show you quickly afterwards. So it's simple Python methods with a tool decorator, and you can define whatever you want inside the tool. So it's absolutely amazing how well it is working when it's working, because it doesn't work all the time. But if you define your tools the proper way and the LLM is able to understand the tool's purpose, then it's working quite great. And to show you what I'm using for tools, so what was of interest to me was to store any information about my watch history inside the database. So I'm using Xata as a PostgreSQL database to store any information regarding my watch history in online, and to be able to add edit entries and do vector search to fetch some information about my preferences and stuff. On the other side, I also gave the model access to TMDB, so the movie database, because the LLM has been trained up to a certain date and it doesn't know about upcoming movies, or maybe like unknown random movies it hasn't heard about. So by giving it access to the TMDB, it's able to fetch some information and retrieve information about upcoming movies. And all of this retrieve information, so enhanced context, is going to be added to the prompt and the query and passed to the LLM that will generate a response, taking everything into consideration. So the agent is handling all three of these, packing them together, sending them to the LLM, getting the response, and forwarding me back the response via the edge-to-speech, the HTTS, so text-to-speech, so I get a voice answer. So it's all working pretty great when it's working again, and we'll demo that quickly. Quick word about the tools I'm using. So Xata, if you don't know it, it's as said, a PostgreSQL service online. It's all online, so you don't need to host the database on your server or on your computer. I don't have a lot of experience using SQL and database, but it was actually super easy to start with Xata, make my account, get an API key, and you can start in no time to create a table and start filling it up with my information, my movie title, the statue list, and some comments. The UI is great to preview your database. The Python API is super easy. And above all, what's super interesting is the integration with langchain. So langchain allows you to store information directly on Xata and store some vectors directly, some embedding vectors directly into Xata along with your information, which allows you to do vector search. So as you will see later, it's easy to then fetch some information from the database based on the nearest neighbors, and well, quickly and easily fetch some information regarding a movie or some preferences. The other tool I'm using is I gave my LLM and my agent access to the TMDB, the movie database. So if you don't know it, it's like the biggest database, movie database online. It's way bigger than IMDb, and unlike IMDb, which is private and owned by Amazon, I think, the TMDB is handled by users, and I think it's open source. The API allows you to query information about something like 80,000 or 100,000 of movie series and everything. So it's quite complete, and it's pretty huge. You can get a free account also, get an API key, and then start querying information. Good thing, for example, if your model needs, if you ask the model information about movies that hasn't been released yet, like for example there is an untitled Jurassic World movie coming next year, obviously GPT-4o mini is not gonna know about this one, so it can fetch information about it and answer any queries you would have about this movie. That's about it, about the tools. The prompt itself is pretty simple. It's defined in Prompt Advisor, GSNL, Inside, if you have a look, you will see that I'm simply defining the usual stuff, giving the LLM its name, its purpose, what it should be doing. I'm explaining it how I organize my movie list, so the movies I've watched and liked, watched and disliked, the movie from my must-see list, and the movie I'm not interested to watch. And the rest is pretty useful stuff. I'm just asking the model to stick to its job, not do something else, and keep it short, basically. Answer in the same language and keep your answer short. I'm also asking it to check the movie list, my watch history before answering and before recommending movies to avoid repetition, but it doesn't always do it. One last note about the prompt is that I originally had a lot of examples, you know, the usual user AI, to help the LLM understand what kind of answers I'm expecting. But I've quickly realized that it was confusing it a lot, and the LLM was having a hard time triggering the tools at the right time, or like was telling me that it will update my watch list but didn't. So I came to, like, I played around with it, and I think you need to find a good compromise. You need to find a good balance between overfloading it with instruction and example, and while giving it the freedom to think for itself, kind of like a child, how you would explain something, so that would try to ride his bike. So in the end, I remove all the example because I had the best results without them. I think there is some room for improvement here, and it should definitely find a good balance between too few and too many examples. For the rest, I'm not going to go into all the file. You have the installation. I try to put all the installation steps, the prerequisite for the APIs keys, etc., the project setup in the GitHub README. So just go through it. It should be quite straightforward to install it and install the submodule. Okay, and for the other file, the important ones, you have the config YAML file that should be copied into AI chatbot to replace the existing one. It contains all the settings about the project. It's a quick way I like to, well, change some settings without putting the end in the code. So you will define your chatbot names, especially very important, the path to the prompt and the path to the tools that you want to use. You have the verbosity of the agent are here, also here. The OpenAI key should be specified here. Your own OpenAI key, HTTPS voices, debug stuff, history stuff. So it's all here. Your environment file also should have your OpenAI key again, your Xata information, and the TMDB API key. Regarding the tools to finish, to show you quickly and so you get an idea, langchain tool, so you can add as many tools as you want to your submodule, to your agent, sorry. A tool is a simple Python method with the tool decorator that is going to perform a given task. So as you can see, I have like 3, 4, 5, 6, 7 tools. The first 4 are adding a movie to one of the different lists: watch like, watch dislike, must see, not interested. This one is searching, is doing a vector search for preferences into the database. This one is querying the TMDB database for information the LLM doesn't know about. And this one is simply getting my current updated watch list. It's very important to name, something I noticed, super important to name your methods and write obvious docstring so the LLM is able to understand what the tool is about and what it should be used for. So very important. I think I changed multiple times the name of my methods on my tools so the LLM is able to trigger them at the right time for the right purpose. If you're interested in all the steps I went through to build this pipeline, you can check the project research Jupyter Notebook, where I'm going through a lot of steps that explored and a lot of things that I tried to build the pipeline. Okay, let's try another demo. So the only difference with the first one is that for this one I put the verbosity of the agents to true. This way we can see what's happening under the hood and the different steps the agent is going through to answer the query. Hey Marlene, do you know a good comedy I could watch with my wife tonight?
How about the Grand Budapest Hotel? It's a quirky comedy that you and your wife might enjoy.
Okay, please ignore the Marlene because of my French accent. She doesn't pick up the name correctly. So what did she do? She did a tool call, get watch list, and she checked my watch list first. This is something I'm explicitly asking her to do in the prompt. So in order not to offer recommendations that are already on my watch list, then she's checking the list first. So she's doing that great. And she's offering the Grand Budapest Hotel, which is an amazing movie. Oh yeah, we watched this one 10 times. It's an amazing movie with so many great actors.
Since you've already watched the Grand Budapest Hotel multiple times and loved it, would you like a different comedy suggestion?
Okay, everything's working as expected. She called the methods to add the Grand Budapest Hotel to my list, to my watch list of movies that I liked, and she copied almost verbatim the comment. Amazing movie with so many great actors. So this is working as expected. Let's try another one. Give me some drama.
How about The Shawshank Redemption? It's a powerful drama that many consider a classic, and it's not on your lists.
Perfect. She checked my watch list again. You can see the Grand Budapest Hotel has been added. Oh yeah, Shawshank Redemption. It's like one of the best movies of the ever. I'm gonna pretend I didn't like it. No, I'm gonna pretend I'm not interested. Yeah, I heard about it, but I'm not interested. It's not the kind of movie we like.
Got it. The Shawshank Redemption is now on your list of movies you don't want to watch. Would you like another drama recommendation?
Okay, so again, all good. She went into the methods to add the movie to my not interested list, copied my comment, not interested, and as we can see, the tool calls are working properly. She's calling the right tools at the right moment. Let's move on to searching the database. So I think inside the database I have West Side Story, and I wrote that I don't like musicals. Here, let's try that. Hey Marilyn, I want to watch a musical tonight, but I forgot, do I like musicals? I actually love musicals. Marlene.
It looks like you don't like musicals, as indicated by your comment on West Side Story. Would you prefer a different genre for tonight?
Alright, again, as expected, she called the right tool. She used the tool to query my preferences, and she used the words musical as query. And she got as a different, like a list of results, but the one with the highest probability was West Side Story, must see, don't like musicals. How is this working? Well, if you check the my Xata database here, apart from the title, status, and comment, I have 2 additional columns. In the content column is written for West Side Story, must see, don't like musicals. So it's a concatenation of the 3 first column, and then an embedding vectors. So what's happening is that when the LLM is adding this information to the database, it's creating this concatenated string, West Side Story, musical. You can see here, for example, it's done it with the Grand Budapest Hotel, watch liked, it's an amazing movie, blah, 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 Shawshank Redemption, same. And it's creating out of it, so using langchain is using the Xata API to create an OpenAI embedding vectors of dimension 1536 elements. And this vector is an encoding of this string here. Why do I do this? It's because then Xata is offering also methods to, with the langchain integration, to search the database using vector search. This is what happened here. Vector search is when you search, you encode a vector, so it used the word musical, it encoded it as an OpenAI vector, and then it searched the vector that was the closest one in the vector space, and it found obviously multiple one, but this one had the highest priority because of the word musical in it. So thanks to this vector search and using the nearest neighbor vector, it was able to extract a list of results in the order of the highest probability, and it's able to use this enhanced prompt to enhance context to answer my question. So this is working fabulous. Let's try another one. I think I have Gone with the Wind. Yeah, Gone with the Wind. I must see it, but I never found the time to watch it. That's true. Hey Marlene, I think I never watched Gone with the Wind, but I forgot why. Is she gonna search for it? Yes.
You haven't watched Gone with the Wind yet because you haven't found the time to see it. Would you like to add it to your watch list?
Okay, as you can see, she did another vector search with the word, with the title completely. So she encoded Gone with the Wind and searched for the nearest vector, and which was Gone with the Wind, must see, never found the time to watch it. So this is working great. It's a quick way to search the database. As you can see, it's very fast and it gives great results. Alright, the last thing I want to show you is the query the TMDB database. So for example, there is a movie Deadpool and Wolverine. I already asked her earlier if she knows about it and she doesn't. But thanks to the TMDB tool, the tool that I give the agent to query the TMDB database, she's able to grab information about it. Hey Marlene, I think there is a movie called Deadpool and Wolverine coming anytime soon. Do you know the plot?
The upcoming movie Deadpool and Wolverine follows Wade Wilson, who is trying to live a normal life after his days as Deadpool. However, he must suit up again to face an existential threat to his homeworld, alongside a reluctant Wolverine. It's set to be released on July 24, 2024.
Suit up. Okay, it's working also as expected. She doesn't have this information, so what is she doing? She's querying the TMDB database because she knows what this is for. To search for information about the movie. She used the query Deadpool and Wolverine. I'm pretty sure the TMDB API is using the same vector similarity search and is returning a dictionary with basically all the information of Deadpool and Wolverine, and then the LLM extracts the plot out of it and is returning it. So this is also working great. You've seen it in the demo, in the first demo, when I'm asking about the upcoming Jurassic Park movie coming next year. It's able to fetch this information from the TMDB database. So this is working great as expected. All right, that's it for the demo. I think this illustrates pretty good what a langchain agent is able to do given the right set of tools, and how it can use these RAG techniques to enhance the context of a query that falls outside of the LLM's reach, and how it can help the LLM give an appropriate answer by enhancing the prompt and the query with the right set of information. This pipeline is used. It's as easy as it is. It's used everywhere, especially like in client support, where you have agents almost everywhere on all the website I'm going. You have an agent coming to you and chatting with you, and this agent is able to reach for information about your previous orders, about previous emails you have sent or communications. So this is quite powerful, and I can imagine like millions of other use cases. For example, right now at the Olympics, you could have an agent that helps you analyze stuff by checking in a huge database. For example, like we've done today, it could fetch from a huge database of athletes and results over maybe like the past century of results, and returns the right set of information to help you in your analysis. That being said, I hope it was helpful for you. Feel free to reach out and ask if you need any help implementing your agent and RAG techniques. And yeah, hopefully see you soon for more tutorials. Take care.